Children, welcome to today's lesson. Today, we will revise our understanding of the first part of kinematics, that is, the motion in a straight line, as well as we'll also do some practice of numerical problems on the motion in a straight line. But first, let us share the learning objective for today's lesson.
On completion of this topic, learners will be able to define motion, recall rectilinear motion, recall velocity, instantaneous velocity, acceleration and average acceleration. Recall the kinematics equation relating initial velocity, final velocity and acceleration for a uniform motion. Solve numerical problems on equations of motion.
Physics swimming art ਵਾਂਗ ਹੈ ਜਿਸ ਨੂੰ ਤੁਹਾਨੂੰ ਸਿੱਖਣਾ ਪੈਂਦਾ ਹੈ। ਤੁਸੀਂ ਸਵਿਮਿੰਗ ਆਰਟ ਤੇ ਬੁੱਕ ਪੜ੍ਹ ਕੇ ਉਸ ਦਾ ਅੱਖਰ ਯਾਦ ਕਰ ਲਵੋ, ਪਰ ਜਦੋਂ ਤੁਸੀਂ ਪਹਿਲੀ ਵਾਰੀ ਪੌਂਡ ਵਿੱਚ ਛਾਲ ਮਾਰਦੇ ਹੋ ਤਾਂ ਤੁਹਾਨੂੰ ਕਈ ਪ੍ਰੋਬਲਮਸ ਆ ਸਕਦੀਆਂ ਹਨ। ਇਸੇ ਤਰ੍ਹਾਂ ਤੁਸੀਂ ਧਿਆਨ ਨਾਲ ਫਿਜ਼ਿਕਸ ਦੀ ਬੁੱਕ ਪੜ੍ਹ ਲਵੋ ਅਤੇ ਇਸ ਵਿੱਚ ਲਿਖਿਆ ਹਰ ਫਾਰਮੂਲਾ ਜ਼ਬਾਨੀ ਯਾਦ ਕਰ ਲਵੋ, ਪਰ ਬੁੱਕ ਖਤਮ ਕਰਨ ਤੋਂ ਬਾਅਦ ਤੁਹਾਨੂੰ ਪਤਾ ਚੱਲਦਾ ਹੈ ਕਿ ਤੁਸੀਂ ਅਜੇ ਫਿਜ਼ਿਕਸ ਨਹੀਂ ਜਾਣਦੇ। ਫਿਜ਼ਿਕਸ ਸਿੱਖਣ ਵਾਸਤੇ ਤੁਹਾਨੂੰ ਬੁੱਕ ਪੜ੍ਹਨ ਤੋਂ ਇਲਾਵਾ ਫਿਜ਼ਿਕਸ ਨਾਲ ਇੰਟਰੈਕਟ ਕਰਨਾ ਹੋਵੇਗਾ ਅਤੇ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਕੇ ਇਸ ਨੂੰ ਪ੍ਰੈਕਟਿਸ ਨਾਲ ਸਿੱਖਣਾ ਹੋਵੇਗਾ। ਮੈਂ ਤੁਹਾਨੂੰ ਫਿਜ਼ਿਕਸ ਵਿੱਚ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨ ਦਾ ਆਮ ਤਰੀਕਾ ਦੱਸਦੀ ਹਾਂ। ਇਹ ਸੁਝਾਅ ਫਿਜ਼ਿਕਸ ਦੇ ਸਾਰੇ ਖੇਤਰਾਂ ਦੀਆਂ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਨ ਵਾਸਤੇ ਵਰਤੇ ਜਾ ਸਕਦੇ ਹਨ। ਇਹ ਮੰਨ ਕੇ ਚਲੋ ਕਿ ਫਿਜ਼ਿਕਸ ਦੀਆਂ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਹੱਲ ਕਰਨ ਲਈ ਕੋਈ ਫਿਕਸਡ ਰੈਸਿਪੀ ਨਹੀਂ ਹੈ। ਇਹ ਸਿਰਜਣਾਤਮਕ ਗਤੀਵਿਧੀ ਹੈ, ਪਰ ਫਿਰ ਵੀ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਨ ਲਈ ਕੁਝ ਗੱਲਾਂ ਵੱਲ ਧਿਆਨ ਦਿੱਤਾ ਜਾਣਾ ਚਾਹੀਦਾ ਹੈ। ਫਰਸਟ, ਰੀਡ ਦ ਪ੍ਰੋਬਲਮ ਕੇਅਰਫੁਲੀ। ਪ੍ਰੋਬਲਮ ਨੂੰ ਸੋਲਵ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਇਹ ਵੇਖਣਾ ਜ਼ਰੂਰੀ ਹੈ ਕਿ ਇਸ ਵਿੱਚ ਕੀ ਸੂਚਨਾ ਦਿੱਤੀ ਗਈ ਹੈ ਅਤੇ ਇਹ ਸਾਡੇ ਕੋਲੋਂ ਕੀ ਪੁੱਛਣਾ ਚਾਹੁੰਦੀ ਹੈ। ਕੁਝ ਸੂਚਨਾ ਸਪਸ਼ਟ ਹੁੰਦੀ ਹੈ, ਜਿਵੇਂ ਇੱਕ ਪ੍ਰੋਬਲਮ ਦੱਸਦੀ ਹੈ ਕਿ ਇੱਕ ਵਿਅਕਤੀ ਦਾ ਮਾਸ 70 ਕਿਲੋਗ੍ਰਾਮ ਹੈ, ਤੇ ਦੂਜੀ ਸੂਚਨਾ ਅਸਪਸ਼ਟ ਹੋ ਸਕਦੀ ਹੈ, ਜਿਵੇਂ ਇੱਕ ਗੇਂਦ ਰੈਸਟ ਦੀ ਪੋਜੀਸ਼ਨ ਤੋਂ ਸੁੱਟੀ ਗਈ ਹੈ, ਭਾਵ ਇਸ ਦੀ ਇਨੀਸ਼ੀਅਲ ਸਪੀਡ 0 ਹੈ। ਇਸ ਲਈ ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨ ਲਈ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਇਸ ਨੂੰ ਧਿਆਨ ਨਾਲ ਪੜ੍ਹਨਾ ਜ਼ਰੂਰੀ ਹੈ। ਦੂਜਾ, ਸਕੈਚ ਐਂਡ ਵਿਜ਼ੂਅਲਾਈਜ਼ ਦ ਸਿਸਟਮ। ਹੋ ਸਕਦਾ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਗ੍ਰਾਫਸ, ਸਕੈਚਸ ਅਤੇ ਡਾਇਗ੍ਰਾਮਸ ਬੜੇ ਕੰਪਲੈਕਸ ਲੱਗਦੇ ਹੋਣ, ਪਰ ਚਾਹ ਕੇ ਵੀ ਇਹਨਾਂ ਤੋਂ ਨਹੀਂ ਬਚਿਆ ਜਾ ਸਕਦਾ। ਇਹ ਸਕੈਚ ਤੁਹਾਨੂੰ ਸਿਸਟਮ ਨੂੰ ਫਿਜ਼ੀਕਲੀ ਸਮਝਣ ਵਿੱਚ ਮਦਦ ਕਰਦਾ ਹੈ। ਇਹ ਸਾਨੂੰ ਦਿੱਤੀਆਂ ਗਈਆਂ ਸੂਚਨਾਵਾਂ ਅਤੇ ਲੱਭਣਯੋਗ ਮਾਤਰਾਵਾਂ ਬਾਰੇ ਹਿੰਟ ਦਿੰਦਾ ਹੈ। ਸਿਸਟਮ ਵਿੱਚ ਵਾਪਰ ਰਹੀ ਹਰ ਘਟਨਾ ਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਧਿਆਨ ਨਾਲ ਵੇਖਣਾ ਅਤੇ ਸਮਝਣਾ ਚਾਹੀਦਾ ਹੈ ਜਿਵੇਂ ਤੁਸੀਂ ਕੋਈ ਮੂਵੀ ਵੇਖਦੇ ਹੋ। ਦੈਨ ਸਟ੍ਰੈਟੇਜੀਜ਼। ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨ ਦੀ ਪ੍ਰਕਿਰਿਆ। ਇਸ ਵਿੱਚ ਇਹ ਸਭ ਤੋਂ ਡਿਫਿਕਲਟ ਪਰ ਸਭ ਤੋਂ ਕੰਸਟਰਕਟਿਵ ਸਟੈਪ ਹੈ। ਆਪਣੇ ਸਕੈਚ ਅਤੇ ਵਿਜ਼ੂਅਲਾਈਜ਼ੇਸ਼ਨ ਤੋਂ ਤੁਸੀਂ ਸਿਸਟਮ ਵਿੱਚ ਕਾਰਜ ਕਰਨ ਵਾਲੀ ਫਿਜ਼ੀਕਲ ਪ੍ਰਕਿਰਿਆ ਨੂੰ ਸਮਝੋ। ਫਿਰ ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨ ਲਈ ਇੱਕ ਯੋਜਨਾ ਬਣਾਓ। That is, identify appropriate equations. ਇੱਕ ਪਲਾਨ ਬਣਾਉਣ ਤੋਂ ਬਾਅਦ specific equations ਲੱਭੋ ਜਿਨ੍ਹਾਂ ਨਾਲ ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨੀ ਹੈ। Then solve the equations. Easy mathematics ਨੂੰ ਵਰਤ ਕੇ equations ਨੂੰ solve ਕਰੋ। Mathematical values ਨੂੰ calculation ਦੇ ਲਾਸਟ ਤੱਕ simplify ਕਰੋ। Finally, check your answer. ਇੱਕ ਵਾਰ ਜਦੋਂ ਤੁਹਾਨੂੰ ਆਨਸਰ ਮਿਲ ਜਾਂਦਾ ਹੈ ਤਾਂ ਇਸ ਆਨਸਰ ਨੂੰ ਵੈਰੀਫਾਈ ਕਰਕੇ ਚੈੱਕ ਕਰੋ ਕਿ ਕੀ ਇਸ ਦੀ ਡਾਇਮੈਂਸ਼ਨ ਸਹੀ ਹੈ, ਕੀ ਮੈਥਮੈਟਿਕਲ ਵੈਲਿਊ ਵਿਸ਼ਵਾਸਯੋਗ ਜਾਂ ਰੀਜ਼ਨੇਬਲ ਹੈ। ਮੈਨੂੰ ਪਤਾ ਹੈ ਕਿ ਪ੍ਰੋਬਲਮ ਨੂੰ ਸੋਲਵ ਕਰਨ ਵਾਸਤੇ ਸ਼ਾਰਟਕਟ ਲੱਭੇ ਜਾਂਦੇ ਹਨ। ਆਸਾਨ ਤਰੀਕਿਆਂ ਨਾਲ ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕੀਤੀ ਜਾਂਦੀ ਹੈ, ਪਰ ਜੇ ਪ੍ਰੋਬਲਮ ਨੂੰ ਸਿਸਟਮੈਟਿਕਲੀ ਸੋਲਵ ਕਰਨ ਵਿੱਚ ਕੋਈ ਕਠਿਨਾਈ ਆਉਂਦੀ ਹੈ ਤਾਂ ਤੁਸੀਂ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨ ਦੇ ਸਾਰੇ ਸਟੈਪਸ ਦਾ ਦੁਬਾਰਾ ਨਿਰੀਖਣ ਕਰੋ। ਤੁਹਾਡਾ ਇਹ ਯਤਨ ਤੁਹਾਨੂੰ ਪ੍ਰੋਬਲਮ ਸੋਲਵ ਕਰਨ ਵਿੱਚ ਨਿਪੁੰਨਤਾ ਪ੍ਰਦਾਨ ਕਰੇਗਾ। ਇਹ ਨਿਪੁੰਨਤਾ ਤੁਹਾਨੂੰ ਐਗਜ਼ਾਮਸ ਵਿੱਚ ਅਤੇ ਕੰਪੀਟੀਸ਼ਨਸ ਵਿੱਚ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨ ਵਿੱਚ ਸਹਾਇਕ ਹੋਵੇਗੀ। ਸਟੂਡੈਂਟਸ, In our previous classes, we have discussed about the equation of motions. Let us recall the equations of motion. I hope you remember that equations of motion can be used to describe a wide range of everyday phenomena. Can you derive the equations describing the motion of an object moving with constant acceleration? Before this, tell me, what is average acceleration? Average acceleration is the time rate of change of velocity. If Vi is the initial velocity at time ti and Vf the final velocity at time tf, then Vf is equal to Vi plus a times tf minus ti. For convenience, let u be the initial velocity at time ti equal to 0 and v is the final velocity at time t. Then the velocity time relation would be v equal to u plus a times t. In place of velocity or acceleration, suppose you have to measure the displacement. Then which relation will you use? Of course, we will use position time relation. Can you derive the position time relation for an object moving with constant acceleration? Do you remember the expression for average velocity? Average velocity is the time rate of change of displacement of an object. Average velocity V average is equal to displacement upon time elapsed, where xf and xi are the position of the object at time tf and ti respectively. This can be rewritten as xf equal to xi plus V average times tf minus ti. For the case of constant acceleration, this relation can be modified by obtaining the relation for average velocity in terms of initial and final velocity. If in the elapsed time velocity changes linearly, then average velocity this time is equal to the sum of initial velocity Vi and final velocity Vf divided by 2. On substituting the value of average velocity in the obtained relation for position, we get xf equal to xi plus Vi times tf minus ti plus half a times the whole square of tf minus ti. This is the general equation for measuring position. For convenience, let u be the initial velocity at time ti equal to 0 and v the final velocity at time t. Let xi be equal to x0 and xf be equal to x. So, we can write the relation as x equal to x0 plus ut plus half at square. If s is the displacement of the object in time t, then x minus x0 is equal to s and the relation becomes s equal to ut plus half at square. In a numerical problem, if initial velocity, final velocity and acceleration are given, then how would you calculate the displacement without knowing how much time is involved? This can be measured with the help of velocity-position relation. How will you obtain this relation? Third equation of motion relates velocity to the position. This we can obtain by eliminating time ti and tf in the first and the second equations of motion. This gives Vf square equal to Vi square plus twice a times xf minus xi. This expression allows us to relate the velocity at one position to the velocity at another position without knowing how much time is involved. Again, for convenience, we use u as the initial velocity and v as the final velocity, x0 as initial position and x as final position. We rewrite the relation as v square equal to u square plus twice a times x minus x0. If s be the displacement of the particle, then the relation becomes v square equal to u square plus twice a times s. All these equations can be obtained using graphical method also. Non-uniform motion ਦੇ ਸੰਬੰਧ ਵਿੱਚ ਅਸੀਂ instantaneous velocity, instantaneous acceleration ਮਿਣਦੇ ਹਾਂ। ਹੁਣ ਇਹ ਸਮਝ ਲਵੋ ਕਿ instantaneous velocity and instantaneous acceleration ਕੀ ਹਨ। Instantaneous time ਤੇ वेग ਜਾਂ velocity ही instantaneous velocity है। Instantaneous velocity can be defined as limiting value of delta x upon delta t as delta t approaches to 0. A x ਦਾ t ਦੇ ਸੰਬੰਧ ਵਿੱਚ ਡੈਰੀਵੇਟਿਵ ਹੈ ਅਤੇ ਇਸ ਨੂੰ dx by dt ਲਿਖਿਆ ਜਾਂਦਾ ਹੈ। Whereas instantaneous acceleration is the limiting value of the average acceleration of the object in a small time interval around that instant when the time interval approaches to 0. Instantaneous acceleration can be defined as limiting value of delta v upon delta t as delta t approaches to 0. This is the derivative of v with respect to t and denoted as dv upon dt. Let us now try to solve problems on equations of motion. A car travels from A to B at the rate of 40 meter per second and return from B to A at the rate of 60 meter per second. Calculate the average speed and the average velocity. It is given that the car travels from A to B at the speed of 40 meter per second and let the distance between A and B be s, and returns from B to A at the speed of 60 meter per second. Let t1 be the time for the journey from A to B, whereas t2 the time for the journey from B to A. Here we may use the formula V average equal to twice V1, V2 upon V1 plus V2. But we have to solve the problem by keeping in mind the different steps to solve a problem. We know that the average speed is equal to total distance upon time elapsed. Here, total distance covered is twice s. Time for the journey from A to B is t1, which is equal to s upon v1 or s upon 40. Similarly, time for journey from B to A is t2, which is equal to s upon v2 or s upon 60. Hence, the average speed would be twice s upon t1 plus t2, that is 2s upon s upon 40 plus s upon 60. This is equal to 2s upon 100s upon 2400 or 2 into 2400 upon 100, that is 48 meter per second. We know that the average velocity is equal to displacement upon time elapsed. Here, displacement is 0 as the car returns to its initial position, hence the average velocity is 0. Let us try another problem. On a highway, two car drivers spot each other when they are just 150 meter apart. They are traveling at 90 kilometers per hour and 126 kilometers per hour respectively. Both of them simultaneously apply brakes, which retard both the cars at a rate of 10 meter per second square. Determine whether they will have a collision or not. Let the initial velocities of the two cars be u1 and u2 and the distance travelled by them before coming to rest be s1 and s2 respectively. Here, u1 is equal to 90 kilometers per hour and u2 is equal to 126 kilometers per hour. For similar unit system, let us convert velocities of the two cars in terms of meter per second by multiplying the initial velocities of the two cars by 5 by 18. Thus, the initial velocities of the two cars in terms of meter per second are u1 equal to 25 meter per second and u2 equal to 35 meter per second. Since after applying the brake, both the cars stop at some distance, therefore their final velocities, say v1 and v2 respectively, becomes 0. Thus, v1 is equal to 0 and v2 is also equal to 0. Here, acceleration of the both cars is minus 10 meter per second square. Hence, a1 and a2 are equal to minus 10 meter per second square. Here, initial velocity, final velocity and acceleration are given. Therefore, the distance travelled by the car can be found with the help of third equation of motion, according to which v square minus u square is equal to 2as. For the first car, by substituting the value of v1, u1 and a1 in place of u, v and a respectively in the equation, we get 0 square minus 25 square equal to 2 into minus 10 into s1, or minus 625 equal to minus 20 into s1. That is, s1 is equal to 31.25 meter. Similarly, for the second car, by substituting the value of v2, u2 and a2 in the place of v, u and a respectively in the third equation of motion, we get 0 square minus 35 square equal to 2 into minus 10 into s2, or minus 1225 equal to minus 20 into s2. That is, s2 is equal to 61.25 meter. Here, total distance covered by the two cars is s1 plus s2, which is equal to 31.25 meter plus 61.25 meter, that is 92.5 meters. As the distance between the two cars when the brakes were applied was 150 meter, which is greater than the total distance moved by the two cars before coming to rest, the collision between two cars will be averted. In the same problem, let me know whether they will have a collision or not if both drivers applied brakes 1 second after they spot each other. Since both cars applied brakes after 1 second, that means both cars would have covered some more distance, that would be 25 meter for the first car and 35 meter for the second car, as their speeds are 25 meter per second and 35 meter per second respectively. In this condition, total distance covered by the two cars is 25 meter plus 35 meter plus s1 plus s2, which is equal to 60 meter plus 92.5 meter, which is 152.5 meter. Here, the distance covered by the two cars before coming to rest is more than 150 meter. Hence, there will be collision between the two cars. Let instantaneous acceleration A of an object in moving with uniform acceleration be given as dv by dt. Can you derive a relation to find the velocity of the object at time t if velocity at time t0 is given as u? We can rewrite the relation for acceleration as dv equal to a times dt. Let us consider at time t, velocity of the object is v, and it is given that at time t0, its velocity is equal to u. On integrating both sides of equation and using the proper limits, that is, integration of dv with the lower and upper limits as u and v respectively is equal to integration of a dt with the lower and upper limits as t0 and t respectively. On simplification, we get v with the lower and upper limits as u and v respectively equal to a into t with the lower and the upper limits as t0 and t respectively. On simplifying the equation, we get v minus u equal to a into t minus t0, which can be rewritten as v equal to u plus a into t minus t0. ਅਸੀਂ instantaneous velocity ਅਤੇ acceleration ਪਤਾ ਕਰਨ ਲਈ ਇੱਕ mathematical problem solve ਕਰਦੇ ਹਾਂ। ਦਿੱਤਾ ਗਿਆ ਹੈ ਕਿ distance s ਬਰਾਬਰ ਹੈ t cube minus 2t square plus 4, ਜਿੱਥੇ time seconds ਵਿੱਚ ਹੈ ਅਤੇ position meters ਵਿੱਚ। ਜੇ time 2 ਸੈਕਿੰਡ ਹੋਵੇ ਤਾਂ position, instantaneous velocity ਅਤੇ acceleration ਇਉਂ ਪਤਾ ਕਰਾਂਗੇ। t बराबर 2 सेकेंड ते पोजीशन है 2 क्यूब माइनस 2 इंटू 2 स्क्वायर प्लस 4, जो बनता है 4 मीटर, क्योंकि बॉडी दी इंस्टेंटेनियस वेलोसिटी इक्वल है ds अपॉन dt। सो s ਨੂੰ t ਦੇ ਸੰਬੰਧ ਵਿੱਚ डिफरेंशिएट करके ਸਾਨੂੰ प्राप्त होता है v इक्वल टू 3t स्क्वायर माइनस 4t प्लस 0। t ਦੀ वैल्यू जो 2 है लगाउण तो बाद सानू प्राप्त होता है v इक्वल टू 12 माइनस 8 इक्वल टू 4 मीटर पर सेकेंड। इसे तरह बॉडी दी इंस्टेंटेनियस एक्सेलरेशन दिती गई है a इक्वल टू dv बाई dt। हुण v दी वैल्यू लगा के जो 3t स्क्वायर माइनस 4t है अते इन्हां नू डिफरेंशिएट करन तो बाद सानू प्राप्त होता है a equal to 60 minus 4। t ਦੀ वैल्यू 2 लगाउण तो बाद सानू प्राप्त होता है a equal to 12 minus 4 equal to 8 meter per second square। Let us try some more problems. A car starts from rest and accelerates uniformly for 20 seconds to a velocity of 25 meter per second. It then runs at a constant velocity and is finally brought to rest in 150 meters with a constant retardation. If the total distance covered by the car is 750 meters, find the value of acceleration, retardation and total time taken. Here, for the first part of the motion, initial velocity u1 is equal to 0 meter per second. Final velocity v1 is equal to 25 meter per second and time t1 is equal to 20 seconds. For the first part of the motion, we use the first equation of motion, that is velocity time relation. The first equation of motion is v1 equal to u1 plus a1 times t1. On substituting the value of v1, u1 and t1 in the equation, we get 25 is equal to 0 plus 20 into a1. On simplification, we get a1 equal to 25 by 20, which is equal to 1.25 meter per second square. Since the equation of motion consisting of position-time relation is s1 equal to u1 into t1 plus half into a1 into t1 square. Now, for determining the distance covered during the first part of the motion, say s1, we substitute the value of u1, t1 and a1 in the relation. We get s1 is equal to 0 into 20 plus 1 by 2 into 1.25 into 20 square. On simplification, we get distance covered by the car in the first part of the motion, that is s1 equal to 250 meters. Let s2 and s3 be the distances covered by the car in the second and the third part of the motion respectively. We know that during the third part of the motion, the distance covered by the car is 150 meters. Since the total distance covered by the car is 750 meters, thus S1 plus S2 plus S3 is equal to 750 meters. By substituting the value of S1 and S3, we get S2 equal to 350 meters. Since the distance covered by the car in the second part of the motion with the uniform velocity 25 meters per second, so the time taken by the car to cover the second part of motion can be calculated as T2 equal to S2 upon V1, that is 350 by 25, which is equal to 14 seconds. ਹੁਣ motion ਦੇ third part ਵਿੱਚ ਅਸੀਂ third equation of motion ਵਰਤਾਂਗੇ। ਇਹ ਅਸੀਂ motion ਦੀ retardation ਜਾਂ motion ਦਾ ਮੰਦਨ ਵੇਖਣ ਲਈ ਵਰਤਾਂਗੇ। ਇਹ ਮੰਦਨ V3 square equal to U3 square plus 2 into A3 into S3 ਹੈ। ਇੱਥੇ initial velocity U3 equal to 25 meter per second, final velocity V3 equal to 0 meter per second ਅਤੇ ਤੈਅ ਕੀਤੀ ਦੂਰੀ S3 equal to 150 meter ਹੈ। V3, U3 ਅਤੇ S3 ਦੀ ਵੈਲਿਊਜ਼ ਇਕੁਏਸ਼ਨ ਵਿੱਚ ਰੱਖ ਦਈਏ ਤੇ ਸਾਨੂੰ ਪ੍ਰਾਪਤ ਹੁੰਦਾ ਹੈ 0 square equal to 25 square plus 2 into A3 into 150। ਇਹ ਹੈ 0 equal to 625 plus 300 into A3। ਇਸ ਲਈ A3 equal to minus 625 upon 300 ਜਾਂ minus 2.083 meter per second square। ਇਹ negative sign ਮੰਦਨ ਜਾਂ retardation ਨੂੰ ਦੱਸਦਾ ਹੈ। Let T3 be the time taken to complete the third part of the motion. Here again we use first equation of motion, that is V3 equal to U3 plus A3 into T3. On substituting the values for U3, V3 and A3, we get 0 equal to 25 minus 2.083 times T3, or T3 is equal to 25 upon 2.083 or 12 seconds. Hence, the total time taken by the car to cover all three parts of the motion is equal to the sum of T1, T2 and T3, that is 20 plus 14 plus 12 or 46 seconds. In our next problem, a car covers 15 meters in 5th second and 17 meters in 6th second. If the motion is uniformly accelerated, how far will it travel in the next second? Here, distance covered by the car in the 5th second, that is S5th, is equal to 15 meters. And in 6th second, that is S6th, is equal to 17 meters. The distance covered by the body in nth second is given by S nth, which is equal to U plus half of A times 2n minus 1. Therefore, for n equal to 5, the equation becomes S5th equal to U plus half of A times 2 into 5 minus 1, which is U plus 9A by 2. On substituting the value of S5th, we get 15 equal to U plus 9A by 2. Similarly, for n equal to 6, the equation becomes S6th equal to U plus half of A times 2 into 6 minus 1, which is U plus 11A by 2. On substituting the value of S6th, we get 17 equal to U plus 11A by 2. On subtracting these two equations, we get 17 minus 15 equal to U plus 11A by 2 minus U plus 9A by 2. On simplification, we get 2 equal to A. Hence, the acceleration of the motion is 2 meter per second square. On substituting the value of A, say in first equation, we get 15 equal to u plus 9 by 2 into 2. On simplification, we get u is equal to 6 meter per second. Hence, the distance travelled in 7th second can be calculated by substituting the values for u, a and n equal to 7 in the relation for distance travelled in nth second. We get s 7th equal to 6 plus 2 by 2 into twice of 7 minus 1, that is 6 plus 13 or 19 meters. So now we come to the end of today's topic. Here's a quick test for you to find out how much have you actually absorbed. Here, instead of complete solutions, I will only provide you the answers so that you can cross-check yourselves. My first question is, when brakes are applied to a car traveling at the velocity of 50 meter per second, its velocity is reduced to 40 meter per second in 5 seconds. Calculate the retardation produced by the brakes. Also, the distance covered in those 5 seconds. The answer is, retardation produced by the brakes would be 2 meter per second square and distance covered by the car would be 225 meters. The next question is, a body is moving with uniform acceleration of 5 meter per second square. If it starts from rest, calculate its displacement after 20 seconds. The answer is, its displacement after 20 seconds would be 1 kilometer. The next question, a bus starts from rest and acquires a velocity of 54 kilometers per hour in 30 seconds. Calculate the acceleration and the distance moved. The answer will be, acceleration of the bus would be 0.5 meter per second square and the distance moved by the bus would be 225 meters. Next question, a car has initial velocity of 54 kilometers per hour. It is accelerated at 3 meter per second square. Calculate the final velocity and the distance covered after 10 seconds. The answer, final velocity of the car would be 45 meter per second or 172 kilometer per hour, and the distance moved by the bus would be 300 meters. Another question is, a body moving with a uniform acceleration travels distances of 18 meters and 24 meters during the first 2 consecutive seconds. Determine the initial velocity and acceleration of the moving body. The answer is, initial velocity of the moving body would be 15 meter per second and acceleration of the body would be 6 meter per second square. Students, I hope you have revised the concept of motion in a straight line as well as complete strategies as how to solve numerical problems. I am confident that you have done all numerical problems. I hope you enjoyed the lesson and are looking forward to the next class. Thank you for your attention and see you next time again.